Hello and welcome to another one of D's ADD videos. Today we're going to be discussing the concept of trig integration, but we're going to be looking at it more advanced than what we saw in our introduction to trig integration. So we're going to first tackle sines and cosines. We're not going to look at sine squared or cosine squared where you have to use the trig identities to reduce the powers to cosine of 2x or sine of 2x depending on the case. We're looking at powers of sine and cosine that are greater than 1. You can't do just plain old substitution either. And basically, what we're going to do is when we're integrating with sines and cosines, and it's not just a simple substitution, meaning that there's some sine to the fourth and cosine to the first, where you could let u equal sine, and then du would be cosine, or vice versa. The exponents are both greater than 1. You're going to look for the odd one, and then you're going to set aside one of those, whatever the odd exponent is, 3 or 5, for instance. And then you're going to convert everything into the other term. Okay, might be a little confusing first. I'm going to go into a little detail. Give me a second. So, look for the odd one on the powers that are greater than 1 on both sine and cosine, and separate one of the odd ones. That's the key there. Okay, look for the odd one out. And then once you do that, it's going to become a u substitution problem. All right, so I've done a couple examples. It's very unorthodox for me to do examples on a concept video, but just to illustrate what I'm talking about, here you see that the powers are both greater than 1, right? So what you're going to do is you're going to look for the odd one and separate it out, because sine is cubed, greater than 1. We set one of the sines aside. So if we set one sine aside, what's left over? A sine squared, 2x. All right. So now what we're going to do is we're going to convert all of these sine squareds into the other term, the cosines. And we know the good old Pythagorean identity can help us with that. Sine squared plus cosine squared equals 1. So when we plug in the Pythagorean identity, we can then do a u substitution. Okay, that's for an example problem video. I'm not going to go into that. Let's look at one more just to make sure you understand the concept. If we're looking at this problem here, we have a fourth and a fifth power. Okay, so we can't just do simple trig identities, so we have to set one of the cosines aside because it's the odd man out, or woman. I don't want to be accused of being gender biased. Here we have a cosine 5x, and we're left with 4 of them. All right, so then what we got to do is we got to convert a cosine to the fourth is the same thing as cosine squared squared. And then we can use the Pythagorean identity plug in, except for the argument's 5x, not 2x, like on the last one. And you're going to plug in what it equals when you solve for the cosine squared. And then it's just a matter of letting u equal this term, and the du will cancel out with all this. All right? So that's basically it for the concept of the sines and cosines when the power is greater than 1. Remember, if it's just a sine squared, convert it into 1 minus cosine 2x over 2. If it's just a cosine squared, 1 plus cosine 2x over 2, and then separate and integrate. All right? That's covered on the very first trig integration video. This is more the advanced stuff. So if what I just said didn't make any sense, go back and review the foundation and then build on it with this one. The next concept one will involve tangents and secants. Look for that. Check out the example videos, and as always, practice, practice, practice is the most important part. Thank you and have a nice day.